Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use conversion factors to solve some simple problems. So let's get into this. So I got 4 problems to go over with you today. So let's start with problem number 1. So problem number 1, we have the diameter of a typical bacteria cells is 3.2 times 10 to the 0 micrometers. What is the diameter in nanometers? So the first thing I want to point out is the way that they've written this in scientific notation, 3.2 times 10 to the 0 micrometers. So the reason I want to point this out is because what is 10 to the 0? 10 to the 0, or any number to the 0 power, is equal to 1. So then 3.2 times 10 to the 0 is the same as 3.2 times 1, which is the same as 3.2. So this is 3.2. The reason I want to point that out is because that is the way you would write a number that's between 1 and 10 in scientific notation. Since this is the number, normally we move the decimal point to the right or to the left, and then we multiply the number we end up with by a factor of 10. But since the decimal point is already to the right of the first number here, you don't move it. So since the exponent on the 10 is related to or comes from the fact that the number of times you move the decimal point, since you're not moving the decimal point at all in order to put it in scientific notation, then the power is going to be 0. So if I wanted to put 9.5 in scientific notation, it would be 9.5 times 10 to the 0. If I wanted to put 1.2 in scientific notation, that would be 1.2 times 10 to the 0. So that's how you put numbers that fall within the range of 1 and 10 into scientific notation. So I just wanted to kind of point that out from the beginning. So let's get into the conversion factor part of this. So we're given a diameter of a typical bacteria as 3.2 times 10 to the 0 micrometers, and they want us to convert that to nanometers. So we got to start with what we're given, and we're going from one prefix unit, micrometers, to another prefix unit, nanometers. When you do conversion factors from one metric unit with a prefix to another metric unit with a prefix in the same category, in this case, length, then you're going to use the base unit as a middleman to convert to. So you're going to convert it to the base unit, in this case meters, and then convert the base unit to the other prefix unit. So let's go ahead and do that. So I'm going to take 3.2 times 10 to the 0 micrometers over 1, and I'm going to convert this to the base unit. So in order to do that, I need to know what micro means. Micro means 1/1,000,000th of a unit. So in this case, it's 1/1,000,000th of a meter. So that's 10 to the negative 6. So I'm going to put 1 micrometer on top, and I'm going to put 10 to the negative 6 meters on the top. I think I said top here. I meant on the bottom. So micrometers goes on the bottom here to cancel out. So micrometers cancels out. And now I have meters on top. And again, just to reiterate, I got this from the fact that I know that micro means 1/1,000,000th of. So 1 micrometer is equal to 1/1,000,000th of a meter. And now that I have that, I'm going to convert the base unit to the other prefix unit, in this case, nanometers. So nano is 1/100000th of the base unit. So in this case, nanometer is 1 billionth, or 10 to the negative 9 meters. So I'm going to put 10 to the negative 9 meters on the bottom and 1 nanometer on top. So meters now cancels out. And now I have nanometers, so I'm done. So at this point, I can multiply by everything on the top, divide by everything on the bottom, and what I end up getting is 3.2 times 10 to the positive 3. So let's double check that. Yep, that is the case. So I get 3.2 times 10 to the positive 3 nanometers. And the way I know that is because if you know your rules for powers, this has a power of 0, this has a power of -6, this is a power of -9 here. They're all base 10. So when you multiply powers together, you're adding the powers. So if they have the same base that you're multiplying. So here 0 plus -6 is going to be -6. But if you divide by a power of 10, then you're going to subtract the power on the bottom, the exponent, from the one on top. So it'd be 0 plus -6, and then minus a -9, which becomes a positive 9. You add that together, and you get a positive 3. Okay, what's next? We have number 2. So number 2 says the mass of a neutron is 1.674929 times 10 to the negative 27 kilograms. We want to convert that to ounces. So we're going to take that number, we're going to take kilograms, 1.674929 times 10 to the negative 27 kilograms. We're going to put that over 1. Okay, we're now going to then convert. Well, we're going to convert kilograms to grams. Well, what does kilo mean? It means 1,000 or 10 to the third. So 1 kilogram is 1,000 grams. So we're going to put that on the bottom. So 1 kilogram goes on the bottom. 10 to the third, or 1,000 grams, goes on top. So we're going to convert that or cancel the kilograms. Next, we can convert grams to pounds if we know the relationship there. So in that case, 453.6 grams is equal to 1 pound. So we can put 453.6 grams on the bottom and 1 pound on top. Let me just double check. Yep, 453.6. So grams cancels out. Now we have pounds. And now we can convert that to ounces, because 16 ounces is exactly equal to 1 pound. So we're going to put 1 pound on the bottom, 16 ounces on top. Pounds cancel out. Now we have ounces. So all we need to do is multiply across the top, divide by the bottom. We get our answer. Now, one thing I forgot to mention about significant figures. Remember, when you multiply and divide, your answer should have the same number of significant figures as the measure with the least number of significant figures, ignoring the exact measurements. So all of these are exact. So this is exact, this is exact, because metric to metric is exact. And so this has 2 sig figs. And so that means that your answer should have 2 sig figs. In scientific notation, the beginning number is the only number you need to worry about when it comes to significant figures. Now, when we go to this problem here, we have 1, 2, 3, 4, 5, 6, 7 significant figures. And here we have, this is exact, so this is going to be ignored. 1 pound is 16 ounces is exact. But grams to pounds is not exact. So we have 4 sig figs here. So that's going to limit this to 4 sig figs. So then when we calculate this out, we limit it 4 sig figs. And the answer we get is 5.908. 5.908. 0388. 0388. Now, here I have 7 sig figs. 1, 2, 3, 4, 5, 6, 7. Here I have 8. Now, if I was going to limit to this number here, to this 7 sig figs, I would have to drop this last 8 and round this to a 9. But since this is the least number of sig figs, we're going to round it to 4 sig figs. So we have 1, 2, 3, 4. So the final answer, I forgot the times 10 here. Times 10 to the negative 26. Negative 26. And that's going to be ounces. Okay. And so when we round this to 4 sig figs, it's going to be 1, 2, 3, 4. So it's going to be 5.908 times 10 to the negative 26 ounces. Now, what about number 3? So number 3, we have the diameter of a human hair this time is 1.70 times 10 to the negative 4 meters. What is the diameter in centimeters? So they want us to convert meters to centimeters. So we're going to start with 1.70 times 10 to the negative 4 meters over 1. Okay. And we want to convert that to centimeters. So this is a one-step conversion because I know the relationship between centimeters and meters. Because centi means 1/100th of. And so if I have a centimeter, that's going to be 1/100th of a meter, or 10 to the negative 2. So I'm going to put on the bottom 1 meter is equal to, 10 to the negative 2 meters. 10 to the negative 2, that's 1/100th of a meter, is equal to 1 centimeter on top. So meters cancels out. And then when I do the calculation, basically, I'm going to divide the 10 to the negative 4 by 10 to the negative 2. That's going to become a positive. And so that's going to become, excuse me, 1.70 times 10 to the negative 2 centimeters. And let me just double check that. Yes. And again, with significant figures, I have 3 sig figs here. This is exact, so we ignore that. So I should end up with 3 sig figs in my answer. So that this should be the right answer with the proper number of sig figs. Same thing with this one. I forgot to circle it or square it or box it. Finally, I have my last problem. The average human body contains 5.2 liters of blood. What is this volume in gallons? So I'm going to start with the 5.2 liters of blood. So I have 5.2 liters over 1. And I want that in gallons. So if I do gallons, so I can do this again in one step. So 1 gallon is 3.785, if I remember correctly. 785, yes. So 3.785 liters. Sorry, I was going to say gallons. Liters on the bottom and 1 gallon on top. Liters cancels out. And when I calculate this, I get 1.37 gallons. And notice that when you multiply and divide, your answer should have the same number of significant figures as the least number of significant figures in your measurements. So here I have 1 and 2. I have 2 sig figs here. Here I have 4 sig figs. 2 is less than 4, so I should have 2 sig figs here. So I'm going to drop the 7. So I'm going to keep the 1, the 3, drop the 7. Because this is a 7, I'm going to round the 3 up to a 4. So my final answer is 1.4 gallons. And so that, ladies and gentlemen, is how you use conversion factors to help you solve problems that require you to convert from one unit to another unit. So I hope this was helpful. If it was helpful, if you enjoyed this video, then please, by all means, like the video, share the video, hit that like button over here somewhere. If you like my channel, subscribe to my channel, hit that notification bell. When you do, click all so you may be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you've got a problem or a question you need help with, put that down below. I would love to help you with that. Thanks for joining me and have a great day.